Right, so I've got this triangle with a parallel line. When that parallel line is drawn, I produce two similar triangles like this. I've labeled them A, B, C, and D, which means in the little triangle, I've got side lengths of A and B. And in the bigger triangle, I've got side lengths of A plus C and B plus D. And because these two triangles are similar, that means that corresponding sides are proportional. So I can say that A is to A plus C as B is to B plus D. Now I'm going to play a little bit fast and furious with some arithmetic here. I'm going to tell you that if you've got a proportion here, that I can flip this proportion over. By the way, you are not responsible for knowing this. You are not responsible for proving this. You are not responsible for being able to fill in a blank version of this. This is just for your information and understanding. But if I have like 1 over 2 equals 5 over 10, and I flip it over so that now I've got 2 over 1 equals 10 over 5, it's still true. It's one of the properties of proportions called the reciprocal property of proportions. And now I'm going to do some other cool stuff here because this is a fraction with a denominator of A. And that means that not only could I, for instance, combine two fractions that have a common denominator, but I can actually separate two fractions. Separate into two fractions, a single fraction, assuming they have the common denominator. In other words, if I had this, you'd feel 100% comfortable going towards this. They have a common denominator, so I can say that the numerator is A plus C over a single denominator of A. And you might not understand yet why I'm doing this, but it's legal. I can separate this into B over B plus D over B. And now you'll notice that A over A is a bigger form of 1, and B over B is a bigger form of 1 as well. So if I just subtract 1 from both sides, what I'm left with is C over A equals D over B. What this proves for us is that when I've got this parallel line, it splits the sides proportionally. So the ratio of these two portions is the same ratio as these two portions. So that's our first theorem here. It's called the triangle proportionality theorem. And it says that if these two lines are parallel, if DE is parallel to AC, then these sides are split proportionally, such that BD is to DA as BE is to EC. The sides are split proportionally. By the way, this is the part you're going to be responsible for, so you should be writing this in. And then the converse would also be true. If I've got a scenario like this with some segment running across here, and that segment happens to split the sides proportionally, in other words, if BD to DA is the same ratio as BE to EC, then I know that this DE segment has to be parallel to AC. It can't happen any other way. What that does for us is it gives us the ability to say, oh, look, I've got some triangles here that have the parallel lines, like we've talked about in this first theorem. As a result, I can set up a proportion. And you remember we talked about this 6-pack of Coke proportion, right? If I choose the number 12 to start with, 12 has two features. It's part of this side, and it's part of the little section up here. So I could say, for example, 12 is to 14 as, now I need 12 is going to be on top here. 12 and 14 are this side, so I'm going to choose this side, but I need 12 and 15 to line up because they're both part of the top segment. And 14 and X are part of the bottom section. This is now a valid proportion. Is it the only one? No. You could have said 12 to 15 is equal to 14 over X. Or you could have said x is to 14 as 15 is to 12. Or you could have said x is to 15 as 14 is to 12. You could not put x over 12. Those have nothing in common. This one's on the bottom side, this one's on the top side, this one's the lower segment, this one's the upper segment. Once you get it set up as a proportion, we can cross multiply to solve. 12 times x equals 14 times 15. 14 times 15 is 210. So 12 times x equals 210. Divide by 12. And we get x is equal to 17.5. Would you please take a moment and do number 2 yourselves now? Go. Can I get a volunteer to please share with me the proportion you set up?
I did x over 18 is equal to 56 over 21.
Perfect. X and 18 have something in common. 56 and 21 have something in common. X and 56 have something in common. 18 and 21 have something in common. Beautiful. You've set it up correctly. It's one of the valid proportions. Now it's just a cross multiply to solve. 21 times x equals 18 times 56. 18 times 56 is 1,008. Divide both sides by 21. And get x is equal to 48. What's your initial impression of how this is going to go for you? 5, I think this is totally doable. This seems really reasonable. 3, if I have some examples here to work with, I think I should be okay. 1, this is kind of confusing. I'm not sure which numbers go where and how to make it all work. Excellent, good scores. Okay. There is a slightly, how do you know which numbers go where? Okay. Do you mean in the original setup? Okay. This is like the discussion we had about the 6-pack. You need the horizontals to match. In other words, x and 56 are both part of the like top triangle, whereas 18 and 21 are both part of these lower cut segments. So they've got something in common. And then x and 18 are both part of the same side of the triangle, and 56 and 21 are both part of the same side of the triangle. What would be inappropriate, in other words, what would not match, is if you try to say something like x is to 21, because then x is the top side of the triangle and 21 is the lower side, but on the other side, those don't match. There's no reason why those should be together. They must be in opposition to each other. So there are a bunch of possible ones. You could have said this one. You could have said that upside down. You could have said the other way around. You could have said 21 is to 18 as 56 is to x. You could have said x is to 56 as 18 is to 21. There's a lot of choices. You just couldn't put those two together. Okay. All right. Now this one is slightly different. What makes it different? Look at the picture and identify what makes this style different.
You need to be able to identify one of the sides of the smaller triangle when given the length of the entire side.
Good. So in other words, we can still say x is to 36, but we don't know this little part here. That's what belongs up here. and then that would go to 45. We can't use 55, that's too big, but we can be smart about this and say, oh, well, I know if 55 is the whole length, and I subtract the bottom part, that'll leave me with what's left up here. In other words, this part is 10, and I can put 10 there. Now I've got it matched up. X is to 36 as 10 is to 45. Or you could do X is to 10 as 36 is to 45. Whichever way makes sense in your head. And then do the cross multiplying and solving. So I'm going to leave problems 4, 6, and 5 as problems for you to do as part of your homework tonight. Page 2. It begins with that converse of what we just did. What we previously said is if these lines are parallel, then these sides are split proportionally. So now what we're saying is if the sides are split proportionally, then the lines should be parallel. So let's see if the sides are split proportionally. I'm going to say 11 is to 15.4 as 10 is to 14. And I'll cross multiply. 11 times 14 equals 10 times 15.4. 140, 154 equals 154. Ah, excellent. It works, which means I can make a conclusion. Remember, 3 dots means therefore. I can say that MN is parallel to JL. And that's my conclusion that I'm making. We're determining if they're parallel. So yes, they are. We'll leave 8 and 9 also as part of your homework. You'll end up with about 12 questions tonight. Turns out that we could take the same idea, and if I were to run another line through the middle here, it would still apply, right? I'd still end up with proportional segments. So it doesn't actually have to be a triangle. If you have 3 parallel lines with 2 segments cutting across them, it'll always make it proportional. So if I know that AB is parallel to CD, which is parallel to EF, then I know that I'm cutting proportionally. AC to CE is going to be the same ratio as BD to DF. And what that means is I can then look at a picture like this, and if the lines are parallel, I can simply set up a similar proportion. 45 is to 18 as 52 is to X. Cross multiply, 45X equals 18 times 52. So 45X equals, how many cards are in 18 decks of cards? 936. Divide by 45, and I get X is equal to 20.8. And you know, I often talk about you giving a precise answer and how using an improper fraction would be great, reducing it to an improper fraction, and to avoid using decimals. I want to be really clear that this time it's okay to use a decimal because it's a terminating decimal, right? It's a decimal that ends precisely. It's not something where I'm rounding it. It's not 20.769371264. It's precise. Okay, I think these are going to be more good practice for proportions without too much of a twist. Well, let's look at number 12. Let's do number 12 together as well. How's this one different? Can I get somebody new to set up this proportion for me?
Well, the first step is going to be subtracting 18 from 32.
Good.
And then once you've done that, you're going to set up x over 27 equals 10 over 18.
Good. 14 over 18, right?
Yeah, sorry. Yeah.
Right. Beautiful, Joe. It's exactly right. So you'd say x is to 27 as 14 is to 18. Cross multiply, and you get 18x equals 14 times 27. Use my calculator to see what 14 times 27 is. 378. Divide by 18. And I get x equals 21. Easy peasy. Okay. Last ones. Sorry, guys, I'm running a little short on time. Last one, we talked about this when we did LR and AR. And we talked about the fact that if I know the ratio of two sides in similar triangles, AB to EF, that's going to be the same ratio as any length comparison, the perimeter, the side lengths, and these special things like altitudes. So BD to FH. And if I took the side length here, in other words, I said QP is to UT, that's setting up the ratio of the length ratios. And that would be the same as QS to UW. And it also works with medians. So GH is to KL as HJ is to LN. In other words, as long as it's a specific type of segment, it's going to be in that same ratio. So we can look at example 1 and say that since this goes to the midpoint of the side and this goes to a midpoint of side, those are called medians and they're the same. So X is to 15 as X is in this triangle. So I'm going to choose 16 because that seems easier to work with than 19.2. But how do I know it goes down here? Is it the 24 or is it the 20? And I can think of two ways to get at that. One is, like we talked about before, if 16 is less than 19.2, then I should choose the one that's less. 20 is less than 24. This is going to be 20 here. But the other way, the more precise way, and the more consistent way, is to recognize that I've chosen 16, which is side length ST. And if I'm looking for the side that's corresponding to it, and I'm given this similarity statement, then I should choose the first two letters here, DE. That's what's corresponding to it. Once I get that set up, I can simply say 20x is equal to 60 times 4 is 240. Divide by 20, and x equals 12. Basically the same thing. It's just that the parts don't look like side lengths. Finish off these three problems and we will be good. Your homework tonight is to submit these 3 completed pages in Canvas. If you have any questions, you can hang out. Otherwise, I'm sorry I kept you 1 minute over. Have a great day and good luck tomorrow. I'll see you via Zoom.